Hi, welcome back. Today we're going to talk about volume of rectangular prisms and how they change if you change an attribute. That's when we're talking about changing the length, the width, or the height of the box. Well, one of the things I enjoy doing, and I was just doing the other day, was going to the movie theater. Now, at the movie theater, it's very expensive to buy all the different treats that they have, all the snacks. But I was really curious to see what's going to happen with the popcorn. How much more popcorn are you going to get if you get a small versus a medium or a medium versus a large? And so that made me think, how is the volume being affected when you change one of the dimensions of the box? If you change the height, the length, or the width of it, what's going to happen to the amount of popcorn that we're going to get now? Well, let's explore. An attribute, something that we're looking to change, or a characteristic of the rectangular prism, is the length, the width, or the height of the shape, whatever shape you're looking at. So it's basically one of the dimensions. Now, when we change one of those, we change it by what we call a scale factor. And a scale factor is a number that's being multiplied by an attribute to change the size of it. So if our scale factor is greater than 1, then our size of our shape is going to get larger. We're going to multiply. But if our scale factor is less than 1, the size is going to get smaller, and therefore we're going to divide. I'd like you to go ahead and pause the video and put this information into your notebook now. Okay, well, let's do some practicing. Let's look. If this were our rectangular prism and we wanted to change it we're going to change the length by a scale factor of 2. What does that mean we're going to do? How is the volume going to be affected when we do that? Well, let's look this over. All right, when we multiply, we're going to multiply this time by 2 because the scale factor. And so let's see, if we have our height over here, and we have our width down here, and we have our length over here. And we remember that the volume is equal to length times width times height, correct? Well, let's look at the original volume. So if we look at what our original value is, if we looked at length times width times height, we were going to multiply 6 times 3 times 2, and we would get, I think I got that wrong. We would get that the volume is 36 feet cubed. So that would be our original volume. So if we're going to change the length by a scale factor of 2, and our length in this case is 6, so we want to figure out, if we're going to do it by 2, it would be 6 times 2. So now our length is now going to equal 12. So we're going to have 12, and our width and our height stay the same. So it's going to be 12 times 3 times 2. So we're going to multiply 12 with your calculator times 3 times 2, and we find that our new volume is 72 feet, and because it's volume, it's cubed again. All right, well, that's interesting. It used to be 36, and now it's 72. What would happen if our scale factor is 1/2? Well, since it's less than 1, since our scale factor is less than 1, then what that means, we're going to divide. And in this case, we're going to divide by the denominator, which is 2. And we're looking at changing the length. So if the length used to be 6, and we're going to now divide by our scale factor of 1/2, so we're going to divide by 2. So let's divide 6 by 2, and we're going to get 3. So again, volume is length times width times height. So our length in this case, when we do a scale factor of 1/2, it's 3. And our width stayed the same, so that's still 3. And our height is the same as well. So it's 2. And so this time, our volume is 18 feet cubed. And if we're looking at this and we're comparing, here we had 36 feet cubed was our original. Our scale factor of 2 made it go up to 72 feet cubed. And our scale factor of 1/2 brought it down to 18 feet cubed. Interesting. Go ahead and pause the video and copy this into your math notebook. Well, let's look at another one. Let's do some more practice. And this time, maybe you want to use your whiteboard or a separate piece of paper. So let's see what's going to happen. We're going to change the height. So we're looking at the height, and we want to do it by a scale factor of 3. So since that's greater than 1, that means we're going to multiply by 3, and we want to find the volume. So here we have our length again, our width, and our height. Well, let's look at our original value, and length times width times height. So we have 10, and when they're side by side, we're multiplying. 10 times 2 times 3, so that would make it 60 centimeters cubed, correct? So 10 times 2 times 3, verifying that on your calculator, you would see that it is 60 centimeters cubed. All right, well, with a scale factor, I'm going to abbreviate, scale factor of 3, I'm going to still do length times width times height. And my length this time is still the same, actually, 10. My width will stay the same to be 2, but my height is now changing. So my height was 3, and I have a scale factor of 3, so I'm going to multiply it by 3, and I'm going to get 9. So now my new height number is 9. So 10 times 2 times 9 is going to give me a scale factor of, or a new dimension, new volume of 180 centimeters cubed. So it was 60, now it's 180. What if I change the height to be a scale factor of 1/3? Well, it's less than 1, so this means we're going to divide by our denominator. So we'll divide by 3, and our height is 3, and we're going to divide it by 3. So now our new height is 1. So we're going to do length times width times height, and our length remained the same, our width remained the same, and our height is now 1. So 10 times 2 times 1, and we're going to find that it is 20 centimeters cubed. Well, I wonder if you're starting to see any connections between our original value and then scale factors going up or even scale factors going down. Something to consider. Let's do one more practice one. This time we're changing our width. So the width is going to change by a scale factor of 4. Again, 4 is greater than 1, so we're going to multiply our width times 4. And here we have our, I'm going to call this our length and our width and our height. Okay, so let's find the original. All right, so length times width times height. So we have 5 times 8 times 10. And when you multiply those together, you're going to find that it should be 400. And we don't know our units, so I'm just going to say units cubed. But let's see what would happen if we did a scale factor of 4 for our width. All right, again, length times width times height is the formula for volume. And our length stays the same, so that's going to stay at 5. And our width is what's changing. So our width was 8. We're going to multiply it by a scale factor of 4. So it's now actually 32. That's quite a change. So we're going to multiply it by 32. and our height stays the same of 10. So 5 times 32 times 10, and our new volume is 1,600 units cubed. Wow. When we multiplied by 4, we had 400 originally, and now we have 1,600. Very interesting. Well, in our next example, we want to see what happens if the scale factor is 1/4. Again, it's less than 1, so that means we're going to divide by our denominator, which is 4, so we're going to divide by 4. And we want to figure out. So the width is 8. We want to divide it by 4, so our new answer is 2. So length times width times height, and our length remains the same, which is 5. Our width has changed, it's now 2. And our height remains the same, which is 10. So you're going to have 5 times 2 times 10, and you should get that that one is 100 units cubed. So we had 400. When we had a scale factor of 4, it went up to 1,600. And when we had a scale factor of 1/4, it went down to 100. Are you thinking any more or seeing any more connections? Well, so this is something important to think about. How does the volume change when one of the attributes is changed? Well, if you said that when you change an attribute, again, which would be length, width, or height by a scale factor, then you probably noticed that the volume of the prism changed the exact same way. If it changed by a scale factor of 2, that means the whole volume changed by a scale factor of 2. It multiplied by 2. If you did a scale factor of 1/4, that means all of the volume was divided by 4. Very interesting. So I want you to go ahead and pause the video and copy this into your notebook now. All right, well, on your turn page tonight, what I'd like for you to do is I'd like for you to find the scale factor or find the new volume of this rectangular prism when you have a scale factor of 2 and when you have a scale factor of 1/2. And when you're going, I want you to do the height is 2. So I want you to do when the height is 2 or when the width is 1/2. All right, so you'll do this in your notebook and we'll talk about it tomorrow to answer any questions you might have. Talk to you later.